There we go.
Cool.
Now you can say,
All right.
now you gotta.
Got it.
Oh, okay. That's fine. And then, now that you're gonna be signed out.
Yeah.
Reboot. Twice today. Yeah, hopefully that's all I'll get today. All right, so a lot of you have heard bits and pieces of this story. Over time, this is kind of my attempt to put it all together, hopefully not overwhelm you and update some of the information. So I'm gonna talk a little bit about me and the program I work for, and then kind of what we've learned over the last 18 years of forest monitoring in national parks, and then also what it means for Acadia. And also want to make sure everyone knows Camilla Sarah also helped me put this presentation together. She's essential to our program, and so this is a collective presentation. Okay, everyone knows the mission of the National Park Service here probably, but I think it's important to always just like remind ourselves. It's different than a lot of other federal land management agencies in that we're mandated to preserve and protect natural resources unimpaired for future generations. So it's kind of the highest level of protection of any federal land management agency. It's also a really high bar to uphold, and it kind of puts us in the business of forever. So thinking really long term about what we're doing, not just like today. But it's hard to know whether we're achieving our mission if we don't know what natural resources we have or what condition they're in. So that's why the Inventory Monitoring Division exists. That's the program Camilla and I work for. And it feels silly to be introducing some of this stuff because everyone's probably heard this a million times. But I didn't know how many new people there were going to be. And this is also kind of for a potential other audience, I think, that I'm giving this for. Anyway, the Inventory Monitoring Division, we conduct baseline inventories and long-term monitoring and important ecosystems to help inform park management decisions. The program is broken into 32 networks, and each network has similar resources and ecosystems. And so Camilla and I work for 3 networks in the Northeast. So we cover 3 networks, 21 parks for Maine and Virginia. We lead the long-term forest monitoring program. I've been with the program since the start in 2006, and then Camilla since 2012. We've been here a long time. That means we just completed our 18th year of monitoring in Acadia. And yeah, I was just thinking about it, like our protocol is old enough to vote now. That's how old it is. And also I think it's worth mentioning that our protocol is adapted from the U.S. Forest Service's Forest Inventory Analysis Program. That's a nationwide survey of plots and allows us to make comparisons with FIA data as well. And that will be important later. Okay, so before I&M, I worked in similar forests in the Great Lakes region. So that's actually me when I was 19 sampling forests in northern Wisconsin in the late 90s. And then I also grew up in southern Indiana, exploring the forests down there. And so my point here is like I've spent my life and career exploring and working in these forests. Kind of all over the eastern forest, and I've watched them change for the better, more often for the worse. And I've seen the full range of forest conditions, from old growth pristine forests to forests that are experiencing collapse right now. And my dissertation also focused a lot on understanding the strengths and weaknesses of the models predicting forest response to change, especially eastern forest response to change. And so these experiences really frame kind of how I think about forest management in parks. And also the potential I see in a forest. And I think you're gonna see kind of the end result of that towards the end of my talk, but like how I'm making sense of what's going on in Acadia. Okay, and so in general, my approach to forest management is about increasing resilience, which a lot of people probably heard this definition, but there are different definitions out there. So we define resilience generally as the capacity of forest ecosystem to absorb disturbance and change while maintaining similar ecosystem functions, composition, and structure. And here, composition is a pretty loose term, like composed of native species, not necessarily the same, but still providing similar function is usually key. And resilient forests are ones that have an abundant regeneration layer, so composed of multiple species and size classes. I'll explain why later, actually. They're also, they have a diverse canopy composed of multiple species in a range of size and age cohorts. They're experiencing minimal impacts of anthropogenic stressors, also, called human stressors. And then they're therefore able to support a broad suite of native forest biodiversity and also support ecological processes like natural disturbances that help to increase structural complexity and diversity over time. So, again, it feels silly because everyone's heard my analogies, but if you think of like a red pine plantation, it's all the same species, all the same size class, all the same age. There's usually no regeneration in the understory. It just takes one pass like red pine scale, which we know too well, to pick out the entire stand, and so that really just means that there's very poor resilience in that stand. There's no guarantee of forest will return. And then if we compare that to a mixed hemlock hardwood stand, there's unlikely to be one pest or stressor that could take out the entire stand. And if it's healthy, there should be a regeneration layer that if you get canopy disturbances, will be able to replace that canopy, grow into that canopy. And so that forest has a lot more resilience to disturbance. And so in IMD, we typically have this objective in mind when we're making management recommendations. And so we're trying to identify any stressors that are reducing or could reduce resilience in the forest, or that are impairing ecological processes or biodiversity that contribute to resilience. And we can't talk about resilience without talking about disturbance and stand dynamics. This is a very simplified version of the kind of expected trajectory that most eastern forests follow, following a major disturbance. And so the figure shows the progression from the initial establishment of often shade intolerant seedlings after a stand replacing fire or stand replacing disturbance, like the aspen and birch that came back after the 47 fire. And then those seedlings grow up to form a canopy where stem exclusion happens. So there's really just like the number of stems reduces. And then pioneer species like aspen and birch, they can't regenerate under their own shade. And so eventually those are, assuming that the stand isn't logged or disturbed, a new cohort of shade tolerant seedlings like red spruce or red maple will start to establish under the canopy, and then eventually they replace the canopy and they become the shade tolerant canopy in the mature overstory. And then as the stand progresses, complexity continues to increase over time. Then you get a full range of size and age classes from the understory to the canopy. You get coarse woody debris and tip-up mounds, which become important microsites for regeneration of other species, which also contributes to diversity. And so in the Acadian spruce fir forest, this fine scale mortality of a single or a few trees really is the most common natural disturbance. And really large scale stand replacing disturbances, like the 47 fire, are really rare, like hundreds to thousands of years rare. Spruce budworm is a disturbance agent in our forests, but it primarily causes mortality of balsam fir, not red spruce. And so across the landscape of these fine scale tree mortality, it leads to a patchwork of species and size classes, and resilience develops over time. So that's forestry or forest ecology 101. And prior to European settlement, the vast majority of New England forests were in these last two stages of succession. That's what most interior forest species are adapted to. And most forests in Acadia and the rest of our parks are in these later stages of succession. And because of that, the presence of a regeneration layer is critical to the resilience of these forests. It's part of their stand dynamics. And so this is a picture from Acadia to kind of demonstrate the concept. So this is a maturing spruce fir forest out at Scudic, and it's starting to develop more of a patchwork of age classes. So I think cores taken from near this plot were in the 110 to 130-year-old range. So it's getting to be transitioning into late successional. And so in the forefront, there are a bunch of little seedlings of spruce. This is growing under a closed canopy forest. And then in the background, this thing's in the way. Let's see if we can get that off. How's that
We
go away?
do a 3 button on the right. We track it now.
Anyway, there's light up here. Well, maybe you can see it right there. There's light, there's a gap, there's a canopy gap. And so what was once probably like these seedlings in the foreground, is now this wall of regeneration behind us. That's because of the canopy gap above it. And so the canopy is being filled from below. So the seedlings are responding to the canopy gap, and they're growing in from below to fill in the canopy. And so this is what forests are supposed to do. Generally, eastern forests, once they reach maturity, they maintain themselves through seedling banks that hang out under a closed canopy until there's a disturbance, and then when a disturbance happens, they respond and they grow up into the canopy. So it's all about filling in the canopy from below. This is a northern hardwood forest example. So this is a closed canopy in the front. You can see it's full of seedlings that are knee to mid-high or mid-thigh height. And then in the back, there's a canopy gap. And so you see that there's more, the regeneration has responded and it's much taller. And kind of the concept here too is that what was present in the regeneration layer at the time of the disturbance is what responds to fill in the canopy after the disturbance. And so here it's mostly sugar maple. Okay, so now when you see a picture like this, hopefully it's obvious to you that there's a problem. So this is from Morristown National Historical Park in New Jersey, but I could have shown similar pictures from other parks in our region. So you see there's a lot of bare ground, there's really no herb or regeneration cover, and so pretty much everything within the reach of deer that's edible is being eaten, and so there's nothing in the understory. And in this case, the seedling bank has been absent for so long that the forest structure has been altered in Morristown. And so as canopy trees die, instead of being filled in from below, the canopy trees are responding and growing bigger crowns. And so it's resulting in trees being wider spaced, like more wider spaced, more evenly sized. We don't have any small trees. And so what's also happening is that the crowns are getting so big that they're actually becoming more subject to wind throw. So, so this forest has very little resilience to disturbance, obviously. There's nothing to replace the canopy, its canopy dies. All right, so even more concerning is when you have severe deer impacts and invasive threats present. So this is a plot from Morristown. Again, this is the first survey in 2009. At the time, there were no seedlings present. And the Japanese barberry, which is an invasive shrub that Jesse and others know too well, that was pretty much the dominant cover in the understory. At the time, it was about waist height. And I remember, you know, as we were setting up the plot, we knew it was a problem. And I remember writing in one of our first forest reports that if this pattern continued, that it could lead to forest loss. And I will say that I thought that this is far off prediction, like end of my career kind of prediction, or later if we let it go on for that long. It's very optimistic thinking, because it took less than a decade for this to actually come true. So it's hard to tell because this is because we lost so many trees from the original scene, but this is the same scene as before. And if you remember, Hurricane Sandy was October 2012. This is May 2013, and the impact from the storm in Morristown was significant. And so a lot of trees went down in a barberry thicket. This is actually before the barberry really had a chance to respond to the increase in light. And we have a tree flag, or this stem flag in the next photo, just for perspective of change. So 4 years later, in 2017, when we sampled this site, there wasn't a single canopy forming tree seedling present in the plot. And the Japanese barberry and multiflora rose and other invasive shrubs are over 6 feet tall, and it's just an impenetrable thicket. And then 4 years later, this was the last year when we sampled it, it's the same. And there's no native seed, no canopy forming seedling present. Somehow the shrubs are even taller, like that multiflora rose corner is like growing its own canopy. It's horrifying. But yeah, it doesn't get better. So here's the full sequence. And it's not just happening in Morristown. So here's an example from Catoctin Mountain Park in Maryland that lost ash in the canopy from 2012 to 2015. I need to make this go away.
If you click on the
If I do what?
can you click on the green your screen share? That'll make it go away. Is that gonna do?
It went away before, without like any,
Can't you drag it down to the corner or something?
Side,
Yeah.
oh. That's better.
Sometimes you
You might be
can,
able to drag it, get it to attach to the side in the black there. And have it go. Just all
I
straight.
can do that, that's better, because now I can see the year, sorry, I didn't realize that was being covered. So right, between 2012 and 2016 is when Emerald Ash Forest took out all their ash. And what responded in the understory was barberry, and that was what was there before, whoops. And then another example from Delaware Water Gap in New Jersey, where a wind disturbance took out the canopy between the first and second survey, and then what you get back is a thicket of Japanese barberry. And then finally, this is a sequence from Saratoga in New York, between the first and third cycle, or so 2008 to 2016. This is exotic honeysuckle increasing under close canopy forest. It just keeps increasing. And then in 2018, a microburst took out the canopy in this plot, including that white pine that you see in the middle. It totally snapped off the crown. And now it's an even thicker honeysuckle thicket with really no regeneration. And so again, when there's a canopy disturbance, what you get in response is what was there to begin with. So if it was invasive shrubs, that's what you get, is what we're finding. This photo's gotten so much mileage, but it's still here. So right, the point I want to make about this one, yes, there are 4 people, Camilla's somewhere hiding in the middle. But the point here is that invasive shrub thickets are not just bad for forest health, but they're bad for people. And so these thickets can carry, or they can, usually like double the densities of ticks occur in these thickets than in uninvaded forests. And then they also are more likely to carry Lyme disease. So these are bad for forests, but also bad for people. Okay, so now that I've shown you what resilience does and doesn't look like, I'm going to summarize what we've learned about the resilience in our forests through our monitoring. And so this northeastern cluster of parks covers 39 parks that have been monitoring forest health using similar protocols for at least 15 years. And that's allowing us to look at regional trends in our forests. And so 2016 and 2018, we published a series of studies that use forest data from parks along with FIA data to compare park forests to surrounding unprotected forests. And we examined multiple metrics of structure and tree diversity. And through those 2 studies, we found that parks protect significant older forest structure compared to surrounding forests. And that includes large trees, standing dead trees, and coarse woody debris. And based on thresholds in the literature that our parks met and that surrounding forests did not, these are ecologically significant results. And so, in other words, our parks have older forest structure that is providing habitat to organisms like woodpeckers, and small mammals, and salamanders, and fungi that really are reliant on large trees and dead wood, and that are pretty much absent outside of the parks. We also found that the park's forests have greater stand level tree diversity than surrounding forests, and putting that together, it's possible that with greater structural complexity and canopy tree diversity, our forests may be more resilient to climate change and other stressors than surrounding forests. And even though most of our parks in the study are small battlefield parks, they are protecting forests that is important beyond the boundaries of the parks. Okay. All right, so that's kind of the good news, just wait. Using the same 39 parks as in the previous studies, we looked at trends in invasive plant abundance. And so while the overall news was bad, so at least, well, 35 out of 39 of those parks had invasive plants, and had at least one invasive plant in at least half of their plots. But we also had at least one significant increase in abundance over 30 parks. Acadia was one of 2 parks that kept very low, like almost 0 abundance of invasive plants in the forest. So Acadia and St. Gaudens, so very low abundance, and then also no significant increases. So it's good for Acadia, not the rest of the region. Okay, so now our latest analysis looked at forest regeneration. And we used a concept called regeneration debt that we developed, where when the bank of seedlings in the understory is insufficient or it doesn't match the canopy, we call it the regeneration debt. And the idea being that when either of those are prolonged, we're either at risk of forest loss in the most extreme cases, which I've kind of already shown examples of, or there's going to be a change in the canopy composition. And this concept is best applied to mature or older forests with a shade tolerant canopy, which most of our parks are composed of. Early successional forests, they have a regeneration debt because the canopy doesn't match the understory. That just is a prediction of change. It's not necessarily a bad thing. And we went further by categorizing regeneration debt into 4 categories. So we have secure, which means the regeneration there is abundant. It comprises a range of size classes and is composed of species found in the canopy. Insecure is where native canopy forming seedlings are sufficient, but saplings are lacking. So saplings are the bigger version of seedlings and they recruit into the tree layer. So they're lacking, and then also they're usually signs of compositional mismatch between the regeneration layer and the canopy. Probable failure is where native canopy seedlings are present at low abundance down. They're present at low abundance. Saplings are basically absent, and they're usually really widespread compositional mismatch. And then imminent failure is where native canopy forming seedlings are nearly absent in the regeneration layer, also no saplings, of course, and forest loss is imminent or already occurring, as we've seen in some cases. And so forests in the imminent failure category, they're really one major disturbance away from forest loss. And as I've already shown, that's starting to happen in the Northeast. And again, the idea here is that when you have a canopy disturbance, what you get is what was already there. If there wasn't anything already there, it's probably not going to be forest. All right, so putting this all together into a regional analysis, we found widespread evidence of regeneration problems. And so we summarized the result into this grid, which I know is hard to read from the screen, but basically every column is a park and every row is an analysis that we looked at. And we used that to come up with the categories of whether a park is an imminent, probable, failure, secure, or insecure. And also, if you see green, it's good. If you see red with a black dot, that's not a good sign. So the key takeaway here is that 2/3 of the parks in this analysis were classified as imminent or probable failure for regeneration. And Acadia is the only park that met secure. When we came up with these definitions, this is not what we expected. Go Acadia.
What were the 2 rows that were red for us?
They're not necessarily bad. So we had a significant decline in sapling density. Let me see.
Yeah,
And sapling basal area and sapling density, but I'll talk about this later. But it's because we had an increase in seedling or in tree density, so the saplings are becoming trees. So it's like healthy forest dynamics. Nobody else experienced that. There's loss in saplings, but because they died, not because they're continuing to grow into
mature the tree.
Yeah, right. Yeah, that's a good question. Okay. This is just putting those categories together on a map so you can kind of see. And I did a similar analysis with FIA data before we started with the park data, and it's basically the same pattern. So it's not like this is a problem restricted to parks, but like we're in the business of caring. So it's a problem because we care about the forest in our parks. Okay, so thinking again about these categories, this is what imminent failure looks like. And again, this is how it often plays out. Probable failure is a little trickier. This does look like a lush understory of lots of green tree seedling, but it's all ironwood or hopcornbeam, people call it, Astraea virginiana. It's a subcanopy tree. It will not form a canopy tree. There are a lot of subcanopy tree species in the Northeast that deer don't really eat, so they tend to respond favorably to deer impacts. They also they're very shade tolerant. They can form really dense stands, and that's what's happening. This is for marsh fillings in Vermont. So we're seeing increases in these low canopy kind of shade tolerant species that are suppressing regeneration with other trees. And then beech also behaves similarly, where beech bark disease is a problem, which is basically our whole network. For insecure, so going back to this picture, there are actually no canopy forming tree seedlings present here. It may look like it, but these are also canopy trees. For insecure, there are no saplings that are native canopy forming, so those two saplings in the picture, those are actually Norway maple. And then the regeneration layer, they're kind of little seedlings, but they're less than a foot tall because deer are keeping them short through chronic browse. And so, yeah, a lot of times this is what insecure looks like. There's no saplings because there's just no opportunity for these seedlings to get bigger because deer are constantly keeping them short and browsing them back. And then finally, this is what secure looks like. This is Acadia. You can see lots of different sizes of seedlings in here. There's also some balsam fir and some spruce. But yeah, this is what a forest can look like when deer aren't eating everything. And just to prove that you can also find this in the northern hardwood forest, I had to go all the way to the upper peninsula of Michigan to find this, but this is what secure looks like in the northern hardwood forest. You don't have to open the canopy to have an abundant regeneration layer in the northern hardwood forest. All right, the final part of the study looked at the potential drivers of these patterns. And so we compared multiple models of anthropogenic stressors, climate change, forest structure, canopy cover, and a combination. And we consistently found that the most important predictors were deer browse impacts, invasive plant cover, physiographic class, that's whether a site's hydric, dry, or mesic, and then tree density in that order of importance generally. And so these results basically tell us what we knew, that we need to deal with the deer and the invasive problem first. And then it's possible we may have to do additional forest management, like thinning the canopy or introducing fire in certain forest types to get the regeneration response that we want. However, it's important to note that these apply to the parks that are in the insecure, probable, or imminent failure, not Acadia. They don't apply to Acadia because it's secure. So that's really, keeping the invasives down is really the key here. Okay, so just to summarize what we found for the region, kind of outside of Acadia, invasive plants are pervasive, they're expanding throughout northeastern parks. We have a serious regeneration problem in 2/3 of our parks, and deer and invasive plants are the primary drivers. And where regeneration is present, we see a lot of signs of compositional mismatch between the understory and the canopy layer. And most concerning are the forests dominated by ash, beech, and subcanopy species because it is at risk. It didn't get into too much detail about that, but that's a problem kind of widespread throughout, but not Acadia. And so that's the bad news for the region. And regional analyses are great because they give you, and they give you perspective, and it kind of like puts Acadia in particular into context. But you miss a lot of details in kind of having to summarize at the regional level. So the next couple of slides are looking at Acadia in more detail. They're kind of the first time. So this is lowest smooth density of live trees over the 18 years of monitoring that we've been doing in Acadia by species or like species group. Hopefully it's obvious to you that red spruce is the most dominant tree species by far. It's like more dominant than all the others put together, and it's been increasing in density over time. 18 years is not that long in the life of a forest. Like, to see such a strong trend is really interesting. The trend is primarily driven by the 47 fire, the stands there. They're transitioning to spruce from birch and aspen, and so we're seeing that signal, and it's kind of continued here. Other trends worth pointing out, so red maple, white cedar, pretty stable. Pine species, so not white pine, but the other pine species, there is like a slight dip because of red pine, but we just don't have a lot of red pine in our plots. It's not super common across the park, so you don't see a strong. There also is a slight decline in the white birches and in aspen because of that successional pattern that I talked about. So that's just natural forest dynamics. So now looking at saplings. So saplings are stems that are a centimeter diameter, so it's like my pinky to 10 centimeters diameter. Anything bigger than that's a tree. And here again, red spruce is a clear winner. What's kind of interesting is you see a dip in red spruce and it starts to go back up. That's because those saplings were recruiting the trees. That's how we got the increase in trees over time in the previous slide. And then there's this dip in other picea, other spruce. I think that's because we're getting better at identifying red versus black. Right?
That would make sense.
Because I see it in seedlings too. So sometimes, yeah, our humanity shows in our data. Yeah, so this is looking at seedlings. So this is from anything from 15 centimeters tall, so like a foot tall, up to a centimeter diameter. And again, spruce is a clear winner. It's continuing to increase in density over time. Again, I think that other spruce dip is us. And then a couple of other things to point out are subcanopy species, which is the pink dotted, that's slightly going down over time. And our other parks for deer browse impacts, that's going up. So that's a good indicator that deer are not causing subcanopy species to increase. It's mostly striped maple here. And then, yeah, I think that's
Is the subcanopy species the line at the very bottom? Which line is the subcanopy species? Sorry.
Nope, it's okay.
It's not a pink one.
It's
Yeah,
this one.
So it's a
Yeah.
very gradual
It's just, yeah.
decline, but is
just a
that
little-
statistically significant?
No, and I'm not gonna base statistical significance on my smoothing right now. I did generate error around the lines, but this is quick and dirty, but it's still the patterns are, yeah, increasing in spruce. I'm guessing.
And it looks like a little decline because the axis, it would be bigger if red spruce weren't on there.
Yes, red spruce
Red
swamps.
spruce makes everything else
Distorts it.
gradual.
Yes,
Yeah.
Even though it's a bigger percentage.
yes, yeah, that's a good point. Okay, I think that's all I wanted to say. And then finally, this is composition of all vascular plants from the ground to 1.5 meters. So that's my eye level. So it's all species. And again, red spruce is a clear winner. So it's red spruce, and then the orange is black huckleberry. And so this is right, like anything that's happening in the understory, whether it's increasing or not, and what its average abundance is. And so black huckleberry is the second one, and then we've got kind of other tree species, ferns, and blueberry species that are kind of making up the middle of like what the dominant species are. Here, not a lot of changes to really talk about. Like I do wonder the dip in blueberry species is around when winter moth was found, and we did kind of see some chewed up blueberries when we were sampling, but it was like we were later than when the winter moth would have been out, so we couldn't like for sure know. So I wonder if that, I don't know if you remember.
Yeah.
Couple other things to point out, the graminoids, which is the yellow here, that's grasses and sedges, that tends to increase when you have deer impacts. And then also, yay for Acadia, the invasive shrubs is basically zero. Like I basically plotted a zero line, red. It stays low the whole time. And again, that is not a trend that we get to say is occurring in many of our parks. So it may seem normal and like, yeah, of course, but like, it's a big deal. And particularly in the parks that are impacted by deer, that's where we see a lot of increases in invasive shrubs. Okay. So this is my first attempt at looking at soil chemistry. So this is O horizon soil chemistry. Again, it's a low smoother. The ribbon is 95% bootstrap confidence interval of the smooth. And I have to give a lot of credit to Camilla for helping me make sense of this, because I'm not an expert in soil chemistry. Camilla knows more than I do. But the key takeaways that we see here, this is actually pretty interesting stuff, is one, there's this inflection point in pH, carried over to aluminum, carried over to calcium. And so the solubility of aluminum as pH approaches 4, and you probably know more chemistry than I do, As it approaches 4, the solubility goes way down, like exponentially. It declines, meaning it doesn't form a solution with other chemicals. And aluminum is toxic to plants and aquatic life, and so less solubility is good. So pH is increasing, aluminum is starting to go down, right around that 4, if you see. Calcium is a similar inflection point, it's the opposite pattern. Calcium is important to plant roots and probably aquatic life, I don't know, but it's important to plants. It's an important nutrient. And it's not quite as tight of a response, and it's also not as strong of an increase. And we know that our soils are poorly buffered, meaning they don't have a lot of calcium. A lot of calcium is probably leached out because of acid deposition. And then granite does not really put off a lot more calcium in its weathering. And so it's not super surprising that the calcium is not, responding really quickly, but it still is going in the right direction. And I think it's amazing that we're seeing these patterns just in like the 18 years we have data for. I think.
So this is an acid rain response. This is like the Clean Air Act doing its job.
Yes, it works.
Is that where the aluminum is from, air emission?
It's released because of more acidic soils from the atmospheric deposition. Yeah.
Acidic soils release the aluminum, and the acidic
Yes.
soils are driven by
Acid
pollution, yeah.
Yes, right. And so as less pollution is hitting the grounds, the soils are recovering, becoming less acidic, and so then aluminum is becoming less available. And that's a good thing. Great. We're gonna take this up with Ivan at some point, I guess, and just like, get his take on it. A couple other interesting things is that the variance here is pretty tight until you hit the inflection point, and then, it's like trumpet shaped. It kind of shows that like a lot of the forest plots were responding similarly, and then they hit that inflection point and there's differences in responses. And so what is behind that is something we're really interested in. Could it be that the Fire 47 has something to do with it? Could it be that thicker soils are responding differently than like the exposed bedrock soils? Like, we're not sure yet. This is like, I did this on Thursday and I said, hey Camilla, what do you think? And it was like chatting back and forth, but it's still pretty interesting. And then other things to look at, percent total nitrogen is going down. I mean, it's barely, if you look at the scale, it's like within 1%, but nitrogen in general, there's not a lot of it in the soil. That's probably because there's been less nitrogen deposition. Clean Air Act again is doing its job. We're not really sure what's going on with percent total carbon. It's also going down. Something that we would like to ask people who know more than us. And then effective cation exchange capacity, it's highly correlated with pH, and so you would expect them both to be increasing together. It is interesting though that it's a much tighter response, and so what's going on there, not totally sure. If anybody has thoughts, I'm totally open to it.
One quick question, but as I'm just thinking, as all these things are kind of shifting around, what else in sort of the soil community, biota and things that might be responding differently, like more active versus less active seasonally, and therefore, it's just when you were mentioning the carbon changes and nitrogen.
Yeah, right. And with carbon, like, this is me showing how little I actually know, but when the pH is different, low versus increasing, whether decomposition is happening by microorganisms or by fungi changes. I think that changes the community of decomposition. So I don't know if that's related. We're not monitoring anything about that, but yeah, it is interesting to look at.
Yeah, you can see in like spruce growth, you can see the effects of acid deposition in the Clean Air Act. So there's been an increase in spruce growth as we've recovered from acid deposition since the 60s. So like, yeah, there's probably really far-reaching effects of the improving situation.
This maybe not is probably beyond your capacity, but if you and Ivan and Jeff and Sarah got together and said like, because they're like, they do a lot of for Jordan Pond, they do a lot of hand waving about what's happening here is because is a result of what's happening in forest soils in the watershed, right? And you have
Yeah.
forest soil data, and so, and all of it's being driven by, responses to the Clean Air Act, but yeah, so it'd be interesting to tie that story all together.
Yep, and, sorry, and I have heard that dissolved organic carbon is a part of the story.
Yeah.
Which, like, there could be something going on. So yes, it would be good to get, people who know these different things together, for sure. And so just to kind of summarize all of this is early evidence of forest soil recovery from atmospheric deposition, from what we can tell, which, the colloquial term is acid rain. And so again, the next step, this is just a smoother, it's a really simple thing to do, is to start modeling with like generalized additive models. And I'll mention that I started doing that just to kind of see if the patterns held up, like the shapes of the line held up, they did. But using GAMs will allow us to actually figure out what predicts those differences, like, the increase in variance or like where the inflection point is today, like looking at spatial variables, like slope aspect, canopy composition, fire 47, that kind of thing. So we definitely want to look into it. And it's something that we're gonna work on this fall, if we can get the right people involved and interested.
Actually, it turns out that Bill and Rachel Fowler are talking about Jordan Pond next week,
Oh, yeah, nice.
next Tuesday.
Okay, I thought you were gonna say, like, it actually turns out that I'm Fernandez is on this webinar.
You're absolutely right.
Yeah, okay. All right, so now just to kind of summarize for Acadia, the good news, for Acadia at least, is that, it's one of the few parks in the Northeast where the forests are healthy and actually even getting better, which I don't really get to say that very often. And so again, it's one of 2 parks in the region where invasives remain low through a monitoring period. 1 out of 39 in the region rated as secure for regeneration. And then there's also this evidence of recovery from atmospheric deposition, both in steady increase in red spruce over time, in all strata in the forest, and then also in the forest soil chemistry. And so I have this photo in the back, because does anyone know what this species is? Can you figure out who that is?
Northern white cedar.
It's northern white cedar, which we see everywhere regenerating in this park. When I moved to Maine, I could not believe how much cedar regeneration there was out here, because it's next to Canada U, it is the most highly prized browse species of deer anywhere, of like woody species anywhere in the East. And so it's the first species you lose in the regeneration layer when you have even slightly elevated deer. So like, it's not regenerating in the Midwest, where I showed the picture of the Upper Peninsula of Michigan. There's no cedar regeneration there because the deer are high enough that they're at least eating it there. And so we have cedar regeneration, we don't have a deer problem. When we start seeing that we have, like, are losing cedar regeneration, that's really when we should start to think about a deer problem. And actually, it can get a lot worse where you just lose the cedar, but nothing else. That's what most of the Great Lakes region is. Okay, so now looking ahead, so like, given how dominant red spruce is, and even that it's increasing in its dominance, like, I know I'm not alone in being concerned about its future, and just the future of Acadia's forests in general. Also concerning is just the overall resilience of the forest is declining because pests are taking out other species. So red pine scale took out a red pine, hemlock woolly delta, it may be a matter of a decade or so before we don't have hemlock anymore. Beech leaf disease is kind of rampaging our beach right now. Emerald ash borer is on the doorstep. And so we're like losing our insurance policy that there's somebody there that can take over when spruce, if spruce declines. And so that is definitely concerning. And so also concerning, this is a figure I stole from Jay Wason's talk in last fall. So even like the best case climate change scenario by 2100, like we far exceed the optimum temperatures where spruce has historically dominated. Another concern. Early climate envelope model predictions, like the climate change tree atlas, they were pretty dire. If you remember, for Acadia, basically it predicted, I think it was like major loss or extirpation of 90% of the most common species in the park by 2100. The latest model predictions are not as dire. So the latest version that came out about a year ago, they still predict loss in spruce, suitable habitat, but they predict red maple and white pine to be pretty much stable over time, even in the worst high emission scenario. And so like, that prediction makes sense to me. Like you have to take these models and think like, does this actually make sense? Like, can I see this playing out? I can see red maple playing out. Red maple is everywhere. It's in the middle of our wetlands. It's constantly dispersing into like every place it can make, it can get to. And it's got a really wide-ranging habitat, from dry to hydric. It could be music if it could outcompete spruce. And then also white pine is kind of similar. So these are two species that like right now, like it's good that we have them, and they're pretty abundant. And so like climate envelope models, they're coarse, they can only be taken so far. They're usually like 20-kilometer grids, which is like almost our park. And so if you want to know more, like if you want to talk more about these climate models, like again, we can like talk about it later. I think we're over-interpreting sometimes what those models are predicting, especially thinking about how the predictions have changed so much between the first iteration and the most recent one. I think the most recent one is more nuanced, it's a lot better, there's a lot more data driving it. But we can't just start like making a lot of changes just based on a model prediction, I guess is what I'm saying. And if we had, we would have probably gone in the wrong direction, perhaps. And also Matthew Duvenek's mechanistic models that he's working on, they are a lot more optimistic about red spruce's future, at least for like the near-term changes, and that only consider climate change. So like he has to put in like a major drought or like a major some kind of disturbance to take out spruce to actually see decline. If everything kind of stays the same except climate change, his modeling kind of shows it looking okay. Hopefully I'm not like spilling the beans on that. I think we've all seen some.
He gave a presentation.
Yeah, right. He gave a presentation.
That's what he said.
As I was talking, I was like, shoot, is this the only information that I was just yeah, but the takeaway here is that not all signs are pointing to red spruce's decline, or like the park's forest, or like the immediate like loss of the forest. There's still reason to be concerned, but right, not all signs are pointing to red spruce loss in like, you know, the next few decades. It's also important to think about how when we talk about the definition of resilience, we talk about function. And so function is really important, like trying to maintain function over time. And especially in Acadia, function is important because conifers function differently than deciduous forests. So conifers, they provide year-round shade, they create cold water stream habitat. They also reduce impacts of spring runoff. So what's interesting about conifers is that they actually catch snow in their canopy, and then the snow sublimates, it becomes water vapor instead of melting and then contributing to the watershed. So generally there's less snowpack under conifers. If you've ever noticed, if you're like, yeah, walking around in the winter, there's less snowpack under the conifers, and then there's less input into the watershed in the spring. It's kind of a good thing. It also makes good deer habitat, or like, yeah, because there's less snow on the ground. But also forests slow runoff from heavy precipitation events, but only conifers do that year round. So when deciduous trees don't have leaves, they don't really slow sheet flow or through flow like conifers do. The other thing to realize is that there are no shade tolerant southern conifers to replace our northern conifers. So our southern conifers are all early successional species that aren't tolerant of shade. The only exception is hemlock. But with hemlock fully adulted and also just kind of lack of good site conditions, like hemlock does need soil. It kind of takes hemlock out of the running as an option. And so to kind of replace our northern conifers with southern conifers, we have to do very different management And it would require major disturbances to persist, like fire and those kinds of things. And so it's really not an option for us. And again, most models predict conversion of spruce fir forest to kind of hardwood. I wouldn't say it'd actually be like sugar maple, because again, we don't have soil, but there is prediction of conversion to hardwood. And there are like foresters and land managers in the area that are starting to shift the composition of their forest to more deciduous, resilient, like climate resilient species. But if you have to make money off of your trees, I can understand the need to do that. I would caution us against trying to do that in Acadia just yet. One, we don't have to make money off of our trees. So when you laugh.
We do make money off of it.
Okay, right.
They have all kinds of economic benefits, some of which are monetary, some of which are not
We
monetary.
don't have to extract the trees. Yes, right, and so we don't have as much to lose, is kind of my point there. Versus if like your livelihood is based on the timber that you're trying to produce, that's a bigger deal. And so I would argue, especially since everything is like trending more spruce, to hold on to that as long as we can. And now think about like what we can do now. I don't want to just like end with like the world might end and that's it. So one is, of course, manage non-climate stressors. In Acadia, that's primarily invasive plants, which you all have such a good control over. I know it feels like it's unending, but yeah, like as we've seen, invasive plants are, you're doing a very good job. Right, so managing non-climate stressors. In other parks, of course, deer management is also really important. And so thinking about managing these non-climate stressors, like there are a few parks that have the capacity to just stay on top of this, let alone take on new projects to do other things. And so this can just be enough, is managing non-climate stressors. It's more than what a lot of other parks can handle. And so I think I feel like I hear, not necessarily from this park, but I hear pressure that like, oh, we have to be doing something for climate change. We have to be like, we have to show that we're making action or we're making change or whatever. And it's like, this can be enough because this is a lot. Anyway, I think another action, which of course I'm biased here, but is continuing to monitor for change. In Acadia, we have a really high plot density. We're sampling a pretty short sampling. And so that should allow us to detect concerning trends pretty quickly. I mean, the fact that we're seeing like increases in spruce the way we are, we should be able, as long as we stay on top of analyzing the data, I think we should be able to see early warnings of problems coming. So that's on us. Continued research, of course, is important. Are we running out of time or something?
Anyhow, it's getting close to one. So
Okay,
people are
this
leaving
is my
the
last one,
presentation.
I think. I'm gonna close.
No, it's totally fine.
Okay, so yeah, continued research is important. So like the common garden experiments, looking at southern trees versus northern tree species to see like who might play best if we need to start pulling from the south. Like that makes a lot of sense. We have to make sure that that research is reversible so we don't accidentally start trajectories we don't need to. So we have to be very cautious about doing that, but it is important. I think also identifying potential spruce refugia is also something that I think there have been a couple of attempts to do. I haven't been fully satisfied by the results. And I'd like to try to use our data to see if we can kind of identify where we think spruce might be able to hold out for a while. May not be everywhere in the park, but if we can find a couple of pockets where we think spruce can persist until, you know, 300 or 400 years from now when climate goes back, like this community is here to like colonize the rest of the park. I think that's a worthy endeavor if we can. Yeah. And then of course scenario planning is essential, so we have plans ready should action be required so that we're not being reactionary. And so this may feel a little bit like we're managing on our heels, but like that's okay. The National Park Service, again, we don't have to profit off of our trees. We're in the forever business, and especially given the trajectory of the forest right now, I don't think directing change in the canopy is really something that we have that much control over. Like when red spruce is doing well, like good luck trying to find something else that's gonna take it over. So yeah, I think like embracing what's happening right now. And I think, yeah, like there's so many forests I work in outside of Acadia that are like 50 or 100 years past the result of like kind of a bad decision, that like it was maybe well-meaning or seemed like a good idea at the time, like planting a bunch of Scots pine in a park or something like that, as a restoration. And it's like, why did you use our native pines? You know, things like that. It makes me also just cautious about trying to make changes to a currently healthy system, I guess. So I think that's all I have. So thanks for your time. I hope it was interesting and some of it was new. And yeah, any questions I can take?
It was all new to me.
Oh.
It was very good.
Thanks.
Yeah.
I'm kind of excited now for the next huge windstorm or major disturbance to see how our secure forests handle it. Which we can already see examples. For the non-climate stressors, which they can be still related with, yes, invasive plants, we're doing what we can. The forest pests, like the ones you mentioned, and pathogens that just in the last 5 years seem to, you know, it's like, what's going on? What would be the one where you would say it's worth putting a lot of effort and capacity towards, if you were to choose one based on your knowledge of what's here now or like likely to come in the next 5 years?
Yeah, that's a good question.
What was your question?
Sorry, for a forced pest disturbance. So thinking of like larger, just that might create a large disturbance based on what we are currently facing. Yeah, that still could lead to, most of our pests are, most of them like single species kind of host, right, or target. So whether it's a beech or hemlock and red pine, kind of already seen that. Pitch pine, ash, pitch pine.
Yeah, like which ones would you fight the hardest?
Yeah, that's kind of
Get established?
not an easy answer.
Yeah,
Curious.
It's tough because like red pine scale happened so fast, right? Like there was really not much we could have done by the time we realized what it was. I think the parks learned from that and tried to be a little more proactive. So I think that's a good thing, like especially with hemlock lily belted. It's like, man, I love hemlock and like the function that it provides is like really important, and where it is, it's pretty dominant. There's not that much hemlock in the park. There's also not that much ash in the park. There's also, you know, like the threats that are coming or that are here, they're hitting species that aren't super dominant right now. But again, it just kind of like takes away from our options and what could replace red spruce. I think if something started attacking red maple, like we're screwed. Like that is like red maple is kind of like, I think everyone's kind of putting their eggs in the red maple basket thinking if we lose red spruce, well, we still have red maple. So yeah. But I think based on function, but ash is but like what can you do about emerald ash borer? I mean, releasing the biocontrols to try to slow it, I think that like that hasn't necessarily been proven to be super effective. I think it's just like, oh, we gotta try something. Something I wonder about with hemlock is that there are some adelgid resistant seedlings that you can get. They're from stuff like North Carolina or something. Like, could they survive here? I don't know, but maybe trying to start planting those resistant hemlock to see if you can get that resistance into the forest. I mean, what do you think? You think about this a lot too.
Yeah, all the time. I think a strategy of as much of slowing the process, and so being realistic that, especially with emerald ash borer, there's no realistic option of prevention, and so it's just thinking of slowing and then allowing for the forest as a whole. So it may not even be that species centric, existence, but just what can have the highest ecosystem function moving forward. And so, like what you're thinking, what might have redundancy of the function it serves. I think hemlock I'm more optimistic that we'll still have hemlock more than 10 years from now,
Nice.
even if we do just a little bit.
Mhm.
But we'll see, right? And so maybe those ones where it might play out over a longer period of time. Maybe that gives us more time and options as we move forward, but the red pines and the ash. And a couple others that once it's, here, it'll only be a couple of years and then they're gone. And I have no idea about beech. Beech is just sort of one of these things where it keeps getting hammered, and we'll see about beech leaf disease, what that does.
Great. Yeah, I mean, beech is already so written off as like a canopy species, or it's considered a pest in places that. Yeah, like I don't think anyone's shedding tears about beech leaf disease in New England, unfortunately. Yeah.
So Abby has a question online. Abby, do you wanna unmute yourself and ask it? If you're still there? There you
Yeah,
are.
I'm still here. Can you guys hear me okay?
Yep.
Okay, great. Yeah, well, just want to say great presentation. And yeah, I guess my question is, with the increase in rain in the past few years, how do you think that precipitation will affect regeneration in Acadia National Park?
Yeah, that's a good question. It like depends on the timing of the rain too. Camilla knows this more than I do. But interestingly, the last like 5 years besides this year have actually been quite dry during the summer. I've been worried about the forest and even wetlands have been crispy to walk in. Like that should be wet and they've been like super dry crispy. This year, not the case. It made wetland monitoring way harder this year than it has been in the past because there's a lot more water. But I think so far spruce is still continuing to increase. We do know that August rain is really a nice predictor of growth the next year. So for spruce really likes late summer rainfall, does very well. But I think what I'm more concerned about is like the swings, having really extreme dry year, a really extreme wet year, like what that is doing to our ecosystems. I think that can be potentially more, especially in wetlands, I guess, and thinking about wetlands can be more destructive than just like a slow trend in one direction.
And you see that in our precipitation, like
Yeah.
some of our driest years on record are recent and some of our wettest years on record are.
Yeah, right. So the variability in our precipitation is increasing over time, even if the trend is maybe going up, we're getting drier years. And that's really something I'm concerned about. I'm sure other people are too. Another analysis that Camilla and I are interested in doing is with our tree core data. We have a lot of spruce tree core data in the park, and actually looking at increment growth and relating that to like rainfall patterns over time and spatial variables so that you could maybe predict where does spruce do well in a wet year? Where does it do poorly in a wet year? Where does it do okay during a dry year? Where does it not? So you can actually predict scenarios of like, if climate continues to get this, then this is where we expect spruce to do well. If it's continuing to get wetter, then this is where we think spruce. So it's like something that I want to do. It's just very complicated modeling with tree cores. So. Yeah, that's a really long answer to the question. Is there anything else? Sorry.
No other questions in the chat. Does anybody else have any questions? And if you're online, feel free to just unmute yourself and go ahead and ask. Yes. No.
I'm curious, it's sort of related, but I'm curious your take on Nova Scotia fires. Because Nova Scotia seems like from a forest ecology standpoint, similar to us. And they had, really large sort of catastrophic fires that damaged a lot of property and did stuff. I'm just curious, like, is there anything that we can learn from that? From your perspective?
It's helpful to have people around and roads around is one big takeaway. People and roads. I mean, where a lot of the wildfires are happening, it's like super wilderness area, not very accessible, and like Canadian Forest Service is having to figure out like how to get there. So I think that's part of the equation that we aren't really hearing about so much. I don't necessarily have all the answers. I do know that a lot of the stands that are burning are like jack pine and white spruce. That's not what we're talking about here, so it's like different species composition.
And that was in Nova Scotia, Jack Pine and White Spruce.
From what I can tell, yeah, there's not like forest ecologists are not talking right now about what's going on, like journalists are talking about what's going on, or firefighters are talking about what's going on. And so it's hard to get the details of what was there before. Like, I suspect that some of the areas that burnt too, not necessarily Nova Scotia, but like they were all over the eastern Canada. In the spring, like some of what might be happening is also in budworm impacted stands, perhaps. I think, like based on where I know the budworm outbreaks are, and where you see the fires are, like there's some correlation there, but I can't find any mention of it in like news or literature.
Yeah.
And like journal articles are just starting to come out to talk about what's going on, and
They must have some fire ecologists out there that, like, it'd be interesting to hear their sort of, you know, people who would be equivalent to like our fire ecologists and
yep,
in the Park Service and Forest Service,
yeah,
and just hear their take on it.
yeah,
Because
totally,
I get that Quebec is a different, you know, like Northwest Quebec is different from us, you know, it's not as different from us as Montana is,
right,
but it's different from us. Nova Scotia, been to Yarmouth, and some of these fires were just outside Yarmouth. I mean, you
Yeah.
spend, I think, us around 5 times, and say you're in Acadia or you're in Yarmouth, and you guys might be able to tell the difference, but I don't think it looks pretty ecologically similar.
yeah. Yeah, so I haven't been able to find as much about what's going on in Nova Scotia, unfortunately, to be able to like help us sleep better at night.
But it's, I'm not losing sleep over this, but I think we're gonna get the questions, you know, I want to be able to intelligently respond to them as much as possible. I think that's where if we can organizationally take some learning from that, and we'll say, well, here's what happened in Nova Scotia, you know, yeah, we have 4 million people that are eyes on our landscape every year that are gonna be able to detect a fire the day it starts.
Mhm.
Maybe that wasn't the case where these were burning in Nova Scotia, maybe it was in more sort of, wildland type circumstances. I'm just curious,
Were
because
they natural or human? Do they know some of their causes of the Nova Scotia ones?
I don't know.
I'm not sure,
They were like, most of them were started with lightning strikes.
Was it before green up or after green up?
it was right around that window
Yeah.
of green up, which is like.
It's like the worst,
entire-
the worst window or whatever,
Yeah.
of risk for us, right?
Yeah.
It seems like our risk is also fall too, right? Like, so there's that window, but then like there's the fall, windy, dry. You know, you have 3 weeks of drought, and then you get like the October winds or November winds, and it seems like there's also a 2 or 4
So
month period.
when we had
Yeah.
our disturbance scenario planning meeting, so when we had our climate change scenario planning meeting, and then we had this separate additional one where we talked about disturbances, and where we ran into, and where we identified the greatest vulnerability is when we get like these multiple disturbances on top of each other, and so it's when you have like a pest outbreak on top
Yeah,
of a
it's
drought.
like an accident, like,
Yeah.
you know, accident statistics, a plane crashes when there's one mistake, and then another mistake,
Right.
and a third mistake, and then you
And-
know, same thing with like accidental fatalities
You
in
know,
parks.
Right, and that was like,
Change.
and I mean, I think we kind of talked about even that. We didn't have the data that we have now, but you know, you were saying that like climate change alone isn't likely to create, it's when we have these other
Yeah.
so wind throw, insects and disease and drought. And then fire coming after a couple of those create a lot of bad conditions. I think that was where the biggest vulnerability was, and right, at some point, we're likely to have a couple of those happen at the same time,
Right.
but it's just a matter of kind of when.
It's,
But
yeah,
But in regular circumstance, like, I think we didn't, at least at that time when we had that workshop, there, you know, until we have those couple of things happen. But in the meantime, we should be, preparing for like how we would respond. You know, when those couple of disturbances happen. Yeah. And which is the scenario planning that
Yeah.
you're talking about.
Yeah, and I will say in like, so I figured that this question was gonna happen. Yeah, no, it's good. Like I've been thinking about it too. And so again, I read as much as I possibly could. And kind of very consistently in the like, how did this happen is that the Canadian Forest Service is not organized. It's like runs like province by province. They're overwhelmed. Like
Yeah.
they were overwhelmed because fires were happening everywhere. Like normally it's like the eastern folks can go out and help the western folks when they need it, and then they, but it was like happening everywhere, and so nobody had.
Was Maine that much different than that? Like, I mean, in the West, in Montana, we're well organized. We've got hotshot crews geographically in close proximity to national forest lands or national park lands, like public lands, whatever. Do we in Maine, we've got Maine Forest Service, we've got a small crew here, like, we don't have, like, we may be more like Nova Scotia in our preparedness level versus Montana. Do you know what I mean? We may be more like that. Anyway, I'm not trying to be chicken little, because I'm not. I've worked in the West where you worry about fire 100 days a year, and here you worry about it 10, if that. But anyway, I don't mean to totally. The other question I had, I was sorry, it's a great presentation, lots of really good food for thought, and maybe no pun intended there, but the slide that you had with all the different yellow and red and colors, could you take that and apply that just to Acadia and look at your different monitoring sites and be able to, because you've often said that Great Meadow is the most ecologically impacted site, so can you actually sort of take that analysis and say, okay, this is Great Meadow, this is Bass Harbor Marsh, this is the Western Mountains, and sort of take all your different monitoring sites and kind of come up with, here's how this would look just at Acadia, not region wide, but just take a sort of zoom in on Acadia, different sites.
We could try. I mean, this is like taking 176 plots and giving it one value.
We've done that
instead of,
sometimes between East and West MDI because of the
Yeah,
fire.
right, we could split,
So
we could
it's
split it
still-
by like unit, but you need,
Kind of big.
you need some replication here to get at that, so looking at individuals, cause like, one of the metrics is like percent of plots that are stocked. And we need at least like 33%.
It's a great visual, I mean, it's a really cool visual, and I can't really see what anything actually
It's in the
says,
publication,
but I like the visual impression of it.
Yeah.
I think it's a great tool.
Yeah, I mean, so we did something similar for wetlands where it was like, so like we could do it ecosystem specifics. We could do like, here's a wetland one, here's a forest one, because it's very different metrics that you're looking at to make comparisons, and I don't think it's always gonna be like apples to oranges to try to compare across ecosystem. But for wetlands, what we did was look at wetlands in Acadia versus the region using EPA's data. And I mean, that just showed that like all of our wetlands, even like Great Meadow is like, compared to when you think of like wetlands in southern New England that are just completely destroyed. Like we rate out really high. And Great Meadow actually was consistently like the lowest of the bunch in Acadia, but still like compared to the region, it wasn't the lowest of the low. We can do something.
I think I've seen you do something like that in the previous.
I was trying to remember, like when we did it, like 2017, I think that's when that report came out, if you saw it.
So what's your plot that is like the most trashed? I guess maybe that's it, it's like.
Forest plot?
Forest plot? Oh, yeah, what is it?
Plot is an Acadia
Compass
plot,
harbor.
but what's one that?
There is a great compass harbor.
Something that's not.
Otherwise, that
very-
would be it.
Where would that be?
Well,
There's the one off Duckbrook Road.
that you guys have treated barbarians.
And then
It's essentially an extension of, suburban Bar Harbor Village and
Yeah.
Paradise Hill.
It's
So-
not really.
Well, it's gonna be where
It's
you get
relative.
the deer,
I
I mean,
think that's what you're
Nice
trying to
plot.
get at.
It's nice.
The range of what's the best.
I know what you.
What,
yeah.
Or are there particular, and again, I can't see this, but are there particular things that we could look at for Acadia as far as we can start to really laser in on, like, what are the what are our risks? Are we seeing particular species and like poor sapling production on one site?
Yeah, that's where, so up here is all like a status, it's like the last 4 years and how we're rating regeneration. Everything down here is the trend that's happening, and so like green is kind of generally a good trend, blue, or red is like after immediate decline. And so like, if we had sapling basal area and sapling density going down, but not tree density going up, we'd be like, ooh, there might be something going on here, like saplings are dying for some reason.
So like to look at that on on an individual monitoring plot level, to be able to say, all right, well,
Yeah.
not only see that occurring, but we don't see that occurring in these other 9 sites in Acadia.
Yeah.
So then let's pay more attention to Great Meadow or whatever. Like,
Yeah.
That's kind of what I'm trying to pay attention for this particular.
Do
Yeah,
you see differences, can you like see like differences in like around the towns? So I was, even like invasive species, like, so we border, Bar Harbor is the biggest, but even the invasive species at Bass Harbor. Are like associated, and those are the places where the deer do come into because there are deer in the towns. That then come into the edges of the park.
And there's past land use that's different,
Yeah.
like more
The past
recent.
land use is
The thing-
different on the edges of
Acadia's
those
just
towns.
so big, like, so Keith's gonna show some of our smaller parks. Acadia's so big that our plots just haven't fallen in, say, Compass Harbor, or like in, like, places that we all know are invaded. Like, obviously Acadia does have invasives in it. We just don't have plots in them.
Right, okay.
yeah, and so all of our other parks, because they're small, we give them this at the end, like after we do the monitoring, and so each one of these pie charts is a plot, and it's showing you like the species composition of the regeneration layer, and also the size of the pies, like how much regeneration you have. These are all done in like, in GIS, well, like, yeah, the analysis is in R, and then the GIS is in ARC. It's hard to try to represent that in Acadia because it's so big with so many plots. My goal eventually is to like make this all into like a dashboard where you can zoom in and out and actually see this kind of thing in Acadia, so you can look at patterns. It's just, I haven't been able to do it, and like, my strategy in Acadia is to give presentations about what's going on, and the other parks, because I'm not there as much, is to give them like documents, I guess. But it's really hard to try to, yeah, represent a park so big, like Scudic we could do, or like Idaho we could do, or even like the eastern section of MDI, it's like, it's big, it's hard to, with how many blocks we have represent, but,
And it's.
But I mean, we're probably most vulnerable on the edges, right? Like, or no?
the edges are, well, I wonder if aspect is gonna get like, that maybe, like spruce right now grows
So
in
stuff-
every aspect, there's no correlation between aspects, like northern, you know, whatever, and spruce, but that's something that could become a
So
thing.
that would become the refugia that you're talking.
Yeah,
Valleys,
what,
all the stream valleys.
possibly, or like northern exposure, maybe able to hang out longer than southern exposure.
What about Idaho? I mean, we hear a lot from the community about how poor the health of Idaho is.
They're forest in transition to late successional forest, I don't know, I mean, it's a hard life to live on Idaho. There's not a lot of soil, probably really acidic conditions, I don't know.
You mean for the plants?
For the plants,
Winds,
yes.
Yeah. One of
It's
the,
beautiful. for
they
people.
meant, so, you know, obviously during the 50s and the 60s, they were measuring acid deposition and stuff. They measured fog. The fog was a pH 3.5, like, just like really like acidic fog out there,
Yeah.
frying all the needles.
Yeah, right,
But presumably that's better now, right?
Yes,
It's
yeah, yeah.
But it's a whole landscape that was so badly damaged from, you know, logging and sheep farming. and
yeah, and lots of
burning,
burning,
and,
right?
you know, it's
Yeah.
like. So,
Not a lot of soil up there, so that's
So that's-
hard.
Well, that was a very good
thank you,
presentation.
great.
Thanks,
Yeah, good job.
Yeah,
Very good. But thank you.
That's
that's why.
one of your INM network sites, is that a part for your INM purposes here? I don't